Hey folks, it's me, Mr. Lang, the guy you haven't met yet. Sorry about that. I figured I'd make this little video to explain to you exactly why you're not seeing me in person. And I also wanted to talk about your assignments for today because I want to do something that's a little more meaty than you having you take notes or watch somebody else's video and do something. I want you to actually do the stuff that I need you to do to get you ready for the test. But first, just so you're aware, here's the deal. I was feeling crummy on Tuesday and kind of jumped the gun. I had some allergy stuff going on, and then added a sore throat and a little bit of a headache, and I was like, oh man, what if? So on my way home, I stopped and I got a COVID test, not realizing that until the results come in, if you've had a COVID test, you're not really supposed to go back to school. So now I'm anxiously awaiting my test result. And if you see me tomorrow, then great. Tomorrow's Friday. And if you don't, then you'll be watching this video. And um, hopefully it won't be any longer than that. It could be, but it probably won't be. Any case, so here is what you need to do today for me. One, hopefully you'll watch this video, so you're following the instructions from the WLP. And the second thing that's on there is asking you to figure out something that you can collect 2 times SEM data for. And you need to collect it from your classmates digitally. I wanted to show you an example, so I made one up. And let me just open that real quickly. So here's the deal. This summer, my family and I constructed a deck. And it's not just any deck, it's a real sweet one. We tore the old deck off, we put the new deck up, and because I'm the dork that I am, I decided that I was going to collect data about deck building. So what I did was I compiled the average number of nails driven per day by my family members by age of family member. So I'll show you pictures of these folks later, but Ben is 12. He started 7th grade in person today in Essex, and he drove 25 nails per day. That's pretty good. And my daughter Zoe, who just started as a freshman at Essex High School, is 14, and she drove 42 nails per day. That is pretty good too. My wife, who is better known maybe as Nurse Josie over at Mallett's Bay School, not to you because you probably had Tammy Freeberg, but anyways, Nurse Josie, who is forever 29, hammered in 130 nails per day. Incredible. And me, Chris, I'm 42, which also happens to be the answer to life, the universe, and everything. We'll talk about that more later. I drove 120 nails per day with a hammer. So this is sort of like the fish data. I just thought of something I could collect data about, and I collected it. And now I'm going to think to myself, well, geez, what questions could I answer with this data? And the answer to that is, well, I could figure out if different age groups drove more or fewer nails, and if that difference is statistically significant. So what I did was I compiled the data by age group. So I have age 20 to 50, which would be Josie and Chris, and I compiled the data for 0 to 19, which would be Ben and Zoe. So if you look here, the average nails driven per day, well, that's just the mean of these two numbers for age 20 to 50, and these two numbers for age 0 to 19. So that's the mean, and then I figured out the standard deviation the same way that you figured it out this summer. I clicked on this cell right here, I hit equals standard deviation, and then I highlighted these 2 points, and it gave me the standard deviation. The count obviously is the number of data points, which is 2. And by the way, you can't really do 2 times SEM graphing if you don't have at least 2 data points. If you don't have 2 data points, you're done because there's no standard deviation between one data point and itself. It's going to be the same. So you can't compare them on this. So the more data points you have, probably the better. Then the square root of the count, same thing, equals square root, and then I clicked on here, Obviously, I did the same things that I showed you to do this summer and dragged that across so that I didn't have to do all the math again and all the entering again for the cells. And then the standard error of the mean, that's just my standard deviation divided by the square root of the count. And then I multiply that by 2 so that I know what to put in for my error bars. Well, then what I did was I did my graph. And if I can scroll down, I'll show you my graph. So here's my graph. And if you look at my graph, you'll see that age 20 to 50, obviously we hammered more nails. You can tell that just by looking at the numbers. But we didn't know if that difference was statistically significant. And I want you to ask yourself right now, looking at this graph, is my result statistically significant? Go ahead, think to yourself. Don't yell it out. Yeah, I see you in the back. Don't yell it out. Just think about it. Got your answer? Okay. Is it significant or not? You can say it out loud now. Go ahead. I'm waiting. Go ahead. Okay. So it is statistically significant. And why? Answer it. That's right, because the error bars don't overlap. What could have made those error bars overlap? Think to yourself, what in the data could have changed to make those error bars overlap? Okay, so if you said that the difference between the points for the 20 to 50-year-olds could have been greater, causing a greater standard deviation, you're right. That's exactly what could cause these error bars to overlap. So the smaller the standard deviation of the points in your data set, the smaller these standard error bars, standard error of the mean bars are going to be. Now I want you to think to yourself, what does this really represent? What does this from here to here really represent? Go ahead, think about it. What does that represent? This is awkward. What it represents is the idea that this is the mean for our collected data set, but based on the data that's present in that set and the standard deviation between the points that make up that data, we could expect the mean to be anywhere from here all the way up to here. That's why if these bars were really overlapping, these bars, we could say that we can't really say that there's a statistically significant difference between our results because the means could fall in the same range as each other. Hopefully that makes sense. Okay, enough of me talking about standard error of the mean. Your job is to come up with something from this summer that you can collect data about. So for example, maybe you want to think about like people who worked this summer versus people who didn't work and how many times they went fishing or went to the beach or went swimming or something like that. You could think about people who work versus don't work and how many masks they own. Maybe that would be something to look into. Nothing medical. So no asking about how many people's COVID tests came back positive or anything like that. And also, you can't take the easy way out when it comes to creating your standard error of the mean graph. So what I did down here was I separated by age. What would be another interesting way that you might be able to come up with two different bars here? Think about another way. Yeah, go ahead right there. Yeah. That's right. You could do male versus female, but that's too easy, and I don't want you to do that. So you need to come up with some other way of differentiating your mean groups. And seriously, the only reason why is because I think male versus female is far too easy. And also I think that it's good for us to move away from gender norms sometimes. So come up with a different way of figuring out a difference between the two groups. That's the first thing that you're doing today once you get done watching me yabber on about standard error of the mean. The second thing that you're going to do today is you're going to do this thing that I call the photosynthesis FRQ, that stands for free response question, scrimmage. What I've done is I've made up a couple of photosynthesis FRQs. And what I'm going to ask you to do is, based on the reading that you did yesterday and the videos that you watched from home that I made the days before, I want to see how much you've absorbed. Does this count as a quiz? Nope. Does it count as a test? Nope. Does a scrimmage go on your record when you're a sports team? No, it's a scrimmage. This is for you to figure yourself out when it comes to this kind of question, and this kind of question is where you're going to lose the majority of your points when it comes to the AP test and the tests that I give you throughout the year, which are based on AP tests. So getting really good at FRQs is a really great way to figure yourself out and get a higher score. So we're going to work on these FRQs all year long. You're going to be able to write them and rewrite them. You're going to love them eventually. But in any case, you're going to get good at writing them, and the College Board is going to love you for it. So I'd like you to go into Google Classroom. I'd like you to go to the Photosynthesis FRQ scrimmage. And as individuals, I want you to try to answer those questions based on what you understand. If you want to look at your notes before you start, that is 100% okay with me because I'm springing this on you. But I don't want you to use your notes during the FRQ scrimmage. Remember, this isn't going to count against you as long as you give it the old college try. I am a happy guy, okay? So those are the things that I want you to do today. Again, I'm really sorry that I can't be there on your first 2 days of AP Biology, which is literally going to be your favorite class of all time. But I can't be, so this is the best I can do. You can see me sitting in my dining room. My front door is over there. And if you have questions, shoot me an email. I hope this helps. Have a great day, and I will see you next week.